Hey guys, so we're going to have a quick look here at Meyer line method. This is question number one. A store owner notices that sales of freezies are higher on hotter days, and he assembles the data in a table. So he measures the temperature on a given day and the number of freezies sold on a given day. And you can probably see the pattern here that as the temperature is warmer, the number of freezies being sold seems to be going up. So it's highly likely that that temperature is causing freezie sales to change. And the question is, what temperature does the model predict if 184 freezies were sold on a given day? So if we know there's 184 sold, what would the temperature likely have been? Well, we could have easily answered this 184 freezie question if we knew the line, or the equation of the line, that modeled the sales of freezies versus temperature in order to make a prediction. So that, if we put a 184 over here where the y is, we could then predict the value of x, or the temperature. The problem is we don't really have the equation of that line, and so we have to find a way to calculate it. We're going to use the data in the table in order to do that. So the first thing we're going to do is divide the data in half. Cut that table this way, horizontally across the middle, leaving me with 4 values for x up here, with 4 values for y, and then 4 values for x over here, and 4 values for y over there. And the next step is to calculate the average x over here and the average y over here, which we'll use as an ordered pair. And then the same thing down on the bottom. We'll do an average x over here and call that x2, and an average y over here and call that y2. So it's just a matter of doing some quick calculations here in order to get these averages. 55 plus 58 plus 64 plus 68 divided by 4, and that gives me 61.25 for the average x of the first 4 numbers in the distribution. And we'll go ahead and get the average y for those first 4 numbers in the distribution. So that's 340 plus 335 plus 410 plus 435, and that comes to 1,520, which we'll divide by 4, giving us 380. And what that will do is that's going to create our P1. In other words, 61.25 for the x with a 380 for the y. That would be our x1 and our y1. And we know for calculating A, we need 2 x's and 2 y's, a P1 and a P2. So we're going to now get the average of the second half of the distribution to create our second point. So to do that, we'll get the average of those x's right there. So that's 70 plus 75 plus 80 plus 84, which comes to 309. We're going to divide that by 4 since there were 4 of them, and 77.25 is my x there. And now for the y, 450 plus 610 plus 735 plus 749 brings me 2,544 divided by 4 gives me 636. So my y2 is equal to 636. So my x2, 77.25, and my y2, sorry, there we go, 77.25, and my y2 is 636. That's x2, y2. So the average of these x's will be the first point in that distribution with those y's, and then the same thing repeating for x2 and y2. So all we do now is calculate our A. A is going to be equal to y2 minus y1, 636 minus 380 over, that's a 3, over 777, 0.25 minus 61.25. Clear that up. 636 minus 380 is 256. And 77.25 minus 61.25 is 16. And when you do that division, you get 16. So the A is 16. We've got to get the B now. I'll pick one of those ordered pairs, plug that into the equation. So 380 for the Y is equal to A, 16, X is 61.25 plus B, 16 times 61.25 is equal to 980. And subtract the 980 from both. So I get 380 minus 980. That gives me negative 600 is my B. So I'll move this over here for a second. And we'll use this part of the screen here to now answer the actual question. Actually, I'll just move this out of the way. So the actual question is, I've got 184 freezies sold, so I know my y equals ax plus b. Y is equal to 16x minus 600. And we know that the number of freezies sold is 184. That's a y. So 184 is equal to 16x minus 600. And I'm going to add 600 to both sides, trying to solve for x here. That gives me 784 is equal to 16x. Come back to the calculator really quickly. 784 divided by 16. I've got to get rid of that multiplication there. And that's going to give me 49. So the x is equal to 49. Now there's your answer. Just quickly to understand what it is that we've done is we've used the table to generate an x1, y1 by averaging the top half and an x2, y2 by averaging the bottom half. And then we used our old slope of a line equation and a substitution of one of those points with that slope to get the b, which gave us our rule, which we then were able to use to answer the question. That's how Meyer line works every time.